Hi everyone, this is Kiranmai from H&S department. Today we are going to discuss about black body radiations. In this topic, we are going to have a look on what is a black body, what is a black body radiation, how to construct a black body artificially, energy distribution by a black body, Planck's law, and from Planck's law we are going to derive about Wien's law and Rayleigh-Jean's formula. First of all, what is a black body? A black body is nothing but a body which absorbs all the radiations which are fallen on it. Neither it reflects them nor transmit them through that. Since it is absorbing all the radiations which are fallen on it, it appears to be black in color. Hence, that body is called as black body. When this black body is heated to some temperatures, it emits radiations which are known as black body radiations. And there is no perfect black body which is existing in nature, but we can construct it artificially. And the first scientist who made the artificial black body is Ferri. The scientist, according to him, a black body can be constructed using a hollow, thick double-walled sphere painted with lamp black inside the sphere. And there will be a circular opening on one side of that hollow sphere, which allows the radiations to enter the cavity. And a projection is made just opposite to the circular opening, which avoids the direct reflection of radiations from the circular opening. And when the radiation enters the cavity, it suffers many reflections inside the sphere and it is finally absorbed by the lamp black surface which is present inside the cavity. When this black body is heated to certain temperature T, according to Stephen, that black body emits a total energy which is directly proportional to the fourth power of the temperature for what it got heated up. E is proportional to T power 4. When you remove proportionality, we have to place one constant which is called as Stephen's constant, represented with a letter sigma. Hence, E is equal to sigma T power 4 is called as Stephen's law. But this Stephen's law can only give you the energy released at a particular temperature T. It cannot explain you any sort of distribution of energy on different wavelength range. For that, two more scientists had came forward and explained the distribution curves of black body. They are Loomer and Prinction. According to them, the emission from a black body at any temperature is composed of radiations of all wavelengths. At a particular temperature, the emission from the black body consists of all radiations. At a given temperature, the energy is not uniformly distributed, but it will be small at very short and very long wavelengths. It will be short and very short and long wavelengths. And the area under the curve, which is covered by this curve, will give you how much energy will be radiated at that particular temperature T. As the temperature of the black body is increasing, the intensity of the radiation emitted also increases. As the temperature increases from T1 to T2, T2 to T3, the energy emitted by the black body is also increasing. And you can observe on the screen that as the temperature is increasing, the wavelength corresponding to the maximum energy is shifting towards lower wavelength side, which is nothing but Wien's displacement law. And mathematically, it can be written as lambda m into T is equal to constant. Now, for a black body, we can derive one more law called as Planck's law, which will give you how much energy will be released at a particular wavelength range, lambda to lambda plus d lambda. It is given by E lambda d lambda is equal to 8 pi hc by lambda power 5 into 1 by exponential hc by lambda kt minus 1 d lambda. So according to Planck's, he made two assumptions in his hypothesis. One is, whatever the radiation entering the cavity, it works like a oscillator, and each oscillator can have a discrete set of energies. That is, a black body consists of number of oscillators inside the cavity of the black body, and each oscillator can have discrete set of energies given by En is equal to nh nu, where n values we can give from 0, 1, 2, 3, and so on. To derive Planck's law, he had considered a black body which is having total n number of oscillators in it with a total energy of E. Then if you want to find out the average energy, the total energy divided by total number of oscillators will give the average energy per oscillator. So let N0, N1, N2, N3, and so on be the oscillators which are having an energies 0, h nu, 2 h nu, 3 h nu, and so on respectively. Now, if you want to find out the total number of oscillators n, just summation of these oscillators will give you how many number of oscillators will be there in the black body. That is, n is equal to n0 plus n1 plus n2 plus n3 and so on. And if you want to find out the total energy of the oscillator, just multiplying the energy of the oscillator with its number will give us the energy of that particular oscillator. Then summation will give you the total energy of the oscillators. Then that is energy of first oscillator 0 into the oscillator number n0, h nu into n1, 2h nu into n2 plus 3h nu into n3 and so on. Since the first term it is multiplied with 0, the first term will be removed. So we are left with an expression E is equal to h nu n1, 2h nu n2 plus 3h nu n3 plus 4h nu n4. So to derive those total energy of the oscillators and the number of oscillators, we are going to take the help of Maxwell Distribution Law, which states that the number of oscillators having the same energy RH nu can be given as NR is equal to N0 into exponential minus RH nu by KT. Now in this expression, the total number of oscillators, in place of N0, we are just going to replace R value with 0. In place of N1, we are going to replace R value with 1. In place of N2, we are going to replace R value with 2. In the same way, with the other terms, we will get an expression N0 exponential function plus N0 exponential function plus N0 exponential function and so on. So from all these expressions, we can have a look at have a common factor n0. So if you take n0 as a common, we had an expression 1 plus exponential minus h nu by kt plus exponential minus 2 h nu by kt plus exponential minus 3 h nu by kt and so on. Now in this expression, consider exponential function as x, then expression can be rewritten as n0 into 1 plus x square plus x cube plus so on, which is a Fourier series for 1 minus x power minus 1. Since the power is negative, if you get that one into the denominator, it will become a positive power n0 by 1 minus x, where x is nothing but an exponential function minus h nu by kt. Replacing x value with the exponential function, the total number of oscillators n is equal to n0 by 1 minus exponential minus h nu by kt. And to find out the total energy of the oscillators, just multiplying the h nu with n1 expression, h2 h nu with n2 expression and so on, just replacing n1 with the help of Maxwell distribution law, we had a common terms of h nu, n2, n0 and exponential function. Just taking them as common, we had an expression 1 plus 2 exponential minus h nu by kt plus 3 exponential minus 2 h nu by kt plus so on. Now again consider the exponential function as x. The equation can be rewritten as h nu and not x into 1 plus 2x plus 3x square plus 4x cube and so on, which is a Fourier series for 1 minus x power minus 2. Again, with a negative power, we can rewrite this expression as h nu and not x by 1 minus x power 2. Again, replacing x value with the exponential function, the total energy of the oscillators is given by h nu and not exponential minus h nu by kt by 1 minus exponential minus h nu by kt whole square. Average energy of the oscillator can be given as E bar is equal to E by N, which is nothing but total energy of the oscillator divided by total number of oscillators. Just replacing E and N with its expressions, we get a final point as h nu by exponential h nu minus 1. The number of oscillators per unit volume in a given frequency range can be written as n is equal to 8 pi nu square by c cube into d nu. These are the number of oscillators which are present in the frequency range nu to nu plus d nu. Now multiplying this number of oscillators with the average energy per oscillator will give us how much energy will be released in that frequency range nu to nu plus d nu. Just multiplying number of oscillators with the average energy per oscillator, we get E nu d nu is equal to 8 pi h nu cube by c cube into 1 by exponential h nu by kt minus 1 d nu. This is nothing but Planck's law, but in terms of frequency. Now, if you want to convert this into the wavelength terms, just replace frequency with a formula nu is equal to c by lambda, where nu and lambda are inversely related to each other. To show that they are inversely related to each other, E nu d nu can be replaced with minus E lambda d lambda, where this negative sign indicates that both frequency and wavelength are inversely related to each other. Now differentiating this nu is equal to c by lambda, we get d nu is equal to minus c by lambda square d lambda. Now just replacing all the frequency terms with the wavelength terms in the above expression, we can change the expression as E lambda d lambda is equal to 8 pi hc by lambda power 5 into 1 by exponential hc by lambda kt minus 1 d lambda, which is nothing but Planck's law in terms of wavelength. Now from this Planck's law, we can derive two more formulas. One is Wien's formula, another one is Rayleigh-Jean's formula. The Wien's formula, which is applicable only at the shorter wavelengths, and Rayleigh-Jean's formula is applicable only at the longer wavelengths. Since for the Wien's law, it is applicable for shorter wavelengths, lambda value will be very small. If lambda value is small, its reciprocal value will be very large, which means that exponential of 1 by lambda into hc by kt, this value is much more greater than 1. So from the denominator, we can neglect 1 from the denominator. Hence, we are left with E lambda d lambda is equal to 8 pi hc by lambda power 5 into 1 by exponential hc by lambda kt d lambda, which is nothing but Wien's formula. Next, Rayleigh-Jean's formula. This is the formula which is applicable on longer wavelength side of the Planck's law. E lambda d lambda is equal to 8 pi hc by lambda power 5 into 1 by exponential. This is the Planck's law. We have to apply this formula for the Rayleigh-Jean's on longer wavelength side, which means that lambda value will be large. If lambda value is large, 1 by lambda value will be small. So if 1 by lambda value is small, squaring of it, cubing of it will make the value much more smaller. Hence, in the exponential function, we are going to neglect higher order terms. So left off with x of exponential hc by lambda kt is equal to 1 plus hc by lambda kt. Now just replacing this term in the Planck's law, we get E lambda d lambda is equal to 8 pi kt by lambda power 4 d lambda, which is nothing but Rayleigh-Jean's formula. Thank you.